So in this video I will talk about, remember in the previous video I said there are 6 possible cases to consider for portfolio theory. So in this case I will talk about case 1 of portfolio theory. Right, so this is the first of the 6 cases. So this is, you should recall the assumption for case 1 is that the losses x1 to xn are IID random variables, and n is the number of investments, is fixed. So this is case 1. Now first thing I'm going to talk about is variable A. The variable A is the total portfolio loss. So I'm going to write down the cumulative distribution function of S is given by this. It's the probability, by definition, is the probability that capital S is less than or equal to a fixed number, little s, and this you can write as follows. This is X, guys. Right, and this becomes equal to, because we are assuming that x1 to xn are IID, right, you can write the product of the density functions, right? By the way, the equality from this to this equality here follows because of the fact that x1 to xn are independent random variables, right? It follows because of this fact, right? All right, in the next step I'm going to use the fact that in this step I'm going to use the following fact, that x1 to xn are identical random variables. Okay, so if you use this fact, then this guy here can be written as the product I from 1 to n of fx xi, then in brackets dxn okay, and the integration is over the same range, that is that the sum of xi is less than or equal to s. Right? So this is the formula for working out the CDF of the total portfolio loss. And I don't expect you to know how to derive this formula, but I will expect you to know how to apply this formula if I give you an example. So I will do some examples later on. Now the PDF of S is just simply the derivative So to note this as the PDF is simply the derivative of the CDF. So this is the formula for the PDF. Now let me do an example. So example 1. Now suppose you have two investments, right, n equal to 2. Then the CDF of S, right, can be written as follows. Right, and which can be written as the integral following the formula I gave you in the previous slide. This is the formula I gave you. Right. Okay, now this integral here, the integral over x1 plus x2 less than equal to s, can be written as a double integral, x1 from minus to plus infinity and x2 from minus infinity to s minus x1. Right. Okay. Now, if you look at this term here, what you have here inside the highlighted area is the CDF of x2 at s minus x1. Right. So basically, this thing here is equal to f x2 at s minus x1, right? So I'm going to write okay, like this. Now, because we are assuming that x1 and x2 have the same distribution, right, you can write this as okay. So this is using the fact that this is using this fact. Okay. All right. Okay. So this is the formula for the CDF of the total portfolio loss when n is equal to 2. Right? The PDF of the total portfolio loss is the derivative of the CDF, which is the derivative of this integral here, right? So let me write it down. Now if you take the derivative inside and differentiate with respect to s, this is what you will get. You will get the integral from minus to plus infinity of x1, and the derivative of this with respect to s is, okay. So this formula gives the PDF of the total portfolio loss when you have two investments. Right. The next thing I'm going to talk about is variable, B, which is about the minimum portfolio loss, right? So this is B. Okay, by definition you can write this as this, and this is the probability that the minimum of is less than equal to u, right? And this you can write as 1 minus the probability that the minimum is greater than u. Right? Now if the minimum is greater than, minimum of these numbers is greater than u, then each of the variables has to be greater. Right, now in the next step I'm going to use the fact that the variables are independent. So using the fact that x1 to xn are independent random variables, you can write it like this. So I have used, let me say here, I have used independence here. Okay, and in the next line I'm going to write this probability as 1 minus the probability that x1 is less than equal to u, and similarly this one as 1 minus the probability that xn is less than equal to u. Right? Okay, now in the next line, because this is a CDF of x1 at u, you can write it as 1 minus f x1 at u, and this is 1 minus f xn at u. Right? And in the next line, because x1 to xn are identical variables, right, what you have is 1 minus, this is the same as 1 minus f x at u, right, and this is 1 minus f x at u. Alright, so that's because of, in this step I have used the assumption that the variables are identical. Okay, so the final the final formula is 1 minus okay. So this is the formula for the CDF of minimum portfolio loss. Now the PDF of minimum portfolio loss is the derivative of the CDF. Right, so if you differentiate this, you get n times 1 minus right, so that's the PDF of the minimum portfolio loss. All right, the next thing I'm going to do is to consider the third variable, which is the maximum portfolio loss. So this is C. So the first thing I'm going to do is to find the CDF of V, which is the maximum portfolio loss. All right, and this you can write as the probability that the max of the n losses is less than or equal to V. Now, if the maximum is less than or equal to a fixed number, then each of these variables has to be. So this is the same as saying that x1 is less than or equal to V up to xn is less than or equal to V. Okay. Now, because x1 to xn are independent variables, you can write this as the product of the probabilities. Right, so it's using, in this step I have used independence. Right, and by definition each of these is a CDF at, so the first one is the CDF at V, the CDF of x1 at V, and this one is the CDF of xn at V. Now, because the variables are identically distributed, this you can write as fx at V, and this you can write as fx at V, right? So that's using the identical assumption, the assumption that the variables are identically distributed, right? So finally, you will get the result that the CDF of maximum portfolio loss is given by this. Right. Okay, now to find the PDF, you just differentiate the CDF. So so if you differentiate this, you get This is what you get. Okay. All right, so that's variable 3. All right, and the next thing I'm going to do is to consider an example. Example 2. So this is example 2 for case 1. Now suppose the losses x1 to xn or IID normal with these parameters. The question is to find the distribution of S, U, and V. Okay. So let's start with S, right? Now you may recall from second year courses or first year courses you have taken that the sum of independent normal variables is also normally distributed, right? So if you don't know that, please look back in the courses you have taken. So the sum of IID normal variables is also normally distributed with parameters, in this case, the mean being n mu, the variance being n sigma squared. You will see this, you must remember this result if you, you may remember this result from the courses you have taken in the past, right? So the CDF of S is just the CDF of this normal variable, which is all right. Here phi denotes the CDF of the standard normal, where phi all right, so that's the CDF. Now the PDF of S is simply the PDF of this normal distribution, which is the following. Right. Here little phi denotes the PDF of the standard normal random variable, right? In other words, it's equal to one over root of 2 pi times exponential minus a half of the square of that, which is okay. So where, let me write again, where phi, little phi, denotes the PDF of the standard normal variable. Okay, so that's part A. Now part B is to consider the distribution of the minimum portfolio loss. So that's what I'm going to do in the next. So for this example, example 2, the CDF of the minimum portfolio loss using the formula that I gave you a few slides ago is given by this. Right. This is the formula. I gave you the formula that is 1 minus 1 minus the CDF of x raised to the power n. So this, I'm using that formula, right? And the PDF of u is just simply the derivative. You should differentiate this with respect to u, you will get the following. Multiplied by 1 over sigma times little 5, which is the PDF of the standard normal. Right. Okay, so this is the PDF of minimum portfolio loss. Now C, the third variable of interest, is the maximum portfolio loss. Right, and once again, using the formula I gave you a couple of slides ago, this is what you will get for the CDF of V. And the PDF of V is simply the derivative of this with respect to V. All right, so this is the CDF of V. So that completes example 2. Now let me do just one more example, example 3. So this is example 3. suppose the losses are IID with exponentially distributed with parameter A. And the question is to find the distributions of S, U, and V. Okay, so let's start with S first. Now there is a result which you might have learned this in your second year or first year. I don't expect you to know this, but there is a result which says that the sum of independent exponential has a gamma distribution with parameters n and a. Right? You might know this from year 1 or year 2. Now the CDF of a gamma variable with parameters n and a is given by this. Again, I don't expect you to know this. It's given by this formula here, right, where gamma n z is defined by the integral from 0 to z of t power n minus 1 e minus t dt. And this is known as the this integral here is known as the incomplete gamma function. All right, that's the name for this integral, right? For this one, right? And the PDF of a gamma variable with parameters n and a is the following. It's a raised to the power n, s raised to the power n minus 1 divided by gamma at n. If you've done the gamma distribution in year 1 or year 2, you will know this, right? So that's for variable A. Now for variable B and C, here we are. For variable B, which is the minimum portfolio loss, the CDF of U is, using this formula that I gave you 2 or 3 slides ago, this is what you will get. 1 minus 1 minus 1 minus e minus, this is the CDF of an exponential random variable, right? So if you simplify this, this becomes, right? And the PDF of U is just simply the derivative of this, which is NA times E minus NAU. So you will see that this is exactly, this itself is an exponential PDF with parameters NA. So what you're saying is that the distribution of the minimum portfolio loss is also exponentially distributed with parameters n, parameter A replaced by NA. The next variable, which is the maximum portfolio loss. So the CDF of V, using the formula I gave you earlier, is 1 minus E minus EA V raised to the power n. So the thing inside the brackets is the CDF of an exponential variable. and the PDF of V is simply the derivative of this with respect to V. Is N. Okay. So this completes example 3. And in the next video, I will talk about case number 2 of portfolio theory.